So let's start with the first measure of dispersion, and it is called the range. So basically the range is the difference between the highest individual score and the lowest score in a distribution. That difference between the highest score and the lowest score in the distribution of the data set is what is called the range, okay? So you are given the data set, or when you are given the scores, like these that you're given here, given the numbers 4, 8, 9, 7, 5, 3. So to find the range of these, you check which one is the biggest number, which is the highest score. And the highest score is 9, then minus the lowest score is 3. Then the difference thereof is 6. So therefore, your range is 6, okay? So to know the range, you just basically find the difference between the highest individual score and the lowest individual score. Is that clear?
Yeah, it's clear.
Okay. If that is clear, we can also move on and see what usually happens. So basically, the grouped data in class intervals, we have for the grouped data in class intervals, the range is actually defined as the difference between the real upper limit, okay, of the highest class interval and the real lower limit of the lower class interval. So you just check the difference. The range is actually the real upper limit of the highest class interval minus the real lower limit of the lowest class interval. That difference gives us the range. For example, referring to the same data above here, we have some data above here. The real upper limit of the highest class range is 6. Okay, the real upper limit of the highest class range, the highest class range we have is from 60 to 64, right? And the lowest is 20 to 24. That is the difference, okay? Then the real upper limit, when you check for the highest limit, for the highest class interval, is actually 64.5, okay, is 64.5, and the lowest one is 19.5. It's basically more like the midpoint. And you get to have that difference. People are not understanding what I mean. When you check this upper limit, okay, between 60 to 64, the next number here that you can find when you add 0.5, of course, you're just adding 0.5 to the highest individual score in the highest class range. Okay, you add 0.5, 64 plus 64.0 plus 0.5 plus 0.5, it becomes 64.5. This is the upper, like the highest number, okay? Then for the lowest, you come to this lowest class, which is from 20 to 24. Then from this number here, which marks the lowest limit, you remove 0.5, okay? You say 20.0 minus 0.5. That gives you 19.5, okay? That is what we are trying to mean. And you know that what you're looking at here, what you're considering is the age of the people. So these are basically the years, okay? So what is the difference? So for your range, you will just say now 64.5 minus 19.5. So you have 45 as the range of the distribution. Is that clear?
It's clear.
Okay. What about the average deviation of the mean? What about the average deviation of the mean? This Actually, it's just as good as the how to find the mean, what we discussed last time. So what you do is you sum all the individual scores. These are the marks for the students from student A through to student E. So these are the marks that they were getting, okay? You add them, 68 plus 70, 67 plus 66 plus 63 plus 61. You sum together. So the summation of the X values, you find 325. You divide that by how many students you have, the individual scores, they are 5, okay? Then you divide that by 5. What you get actually is the what? Is the mean, okay? We say the mean is found by saying the summation of these X variables divide by N, okay? When you divide by N, that is how you find the mean. Is that clear?
Yeah, it's clear.
Okay. If that is clear now, let's talk about the deviations. The deviations. We have found that very, very important to follow nicely. The mean is 65. That's what we've said, 65. The individual scores for student A is 68, 67, 66, 63, and 61 for E. Okay, these are the X variables. So if you want to get the deviations, all right? So you want to get the deviations, you're basically getting the numbers that are moving from the individual score, then minus the mean. That difference is what gives us the deviation. For example, here, the X variables are these, okay, the marks. So you say 68 minus what? Minus the mean. Or you say the mean, the X bar is 65. 65. So you say 68 minus 60 what? 65. Yeah. You find positive 3, right? That is the deviation. Okay, the deviation is basically the difference, okay, or the distance of an individual score from the center, from the mean, okay? From the mean, how far is each individual score from the mean? That is the question you are asking yourself. So for example, this one, the deviation of this one from the center, the average that almost everyone got, okay, on average, everyone got 65. They are around 65. That is the average. Then how far is this person from the average? It's just 3 units above, okay, above the average. Then B is 2 units above the average. You say 67 minus 65, which is the mean, okay? 2 units above. This one is just 1 unit above. This one is 2 units below, because it's 63 minus 65, that gives us -2. And this one is 4 units below the average, right? So basically this measures the deviations. It measures the deviations from the mean. That is how far each individual score is from the center or from the mean, from the average, okay? When you talk about the absolute value thereof, to get the absolute value simply means when you make these positive, you just assume each number is positive. That is the absolute value of the deviations. So they will just be positives, all of them. That is if you take the absolute. Absolute value simply means having positive values, not having negatives, right? So the absolute deviations are these. Any question? Okay. There is no question, then we can continue. We can proceed. So what you can do actually, you can find the average, okay? You can actually find the average of deviations. Now, the average of deviation is actually the summation of the average deviations. How do you find the average deviations? You say X variable minus the X bar, which is the mean. You sum this sigma this symbol means add, summing up. You divide by n. This is how you find the average of deviations. So when you sum up all the deviations, okay, all these deviations, these here, you can see the deviations in the background here. There is 3 plus 2 plus 1 plus 2 plus 4. What do you find? This is 5, this is 3, and this is 4. You find 12, right? This is the total sum of the deviations, the x minus 2 bar. So you have 12. You divide by how many students are there? They are 5. So that's how to find the average of deviations. So you get the deviations, you sum the deviations, then you divide by how many deviations you have, especially in terms of their classes. So when you do your division, you say 12 divided by 5, that gives you 2.4, right? Now this 2.4 actually is the average of deviations, AD. The average of deviation is also a measure of central tendency. Sometimes now you can have the grouped data, the data that is grouped in groups, okay? For example, you have the age group. The people who are aged 20 to 24, others are from 20 to 29, the others are 40 from 44. Okay, the co-host, you can actually mute the mic of that person unless you are the one. Yes. Okay, so you have the age range from 20 to 24. The other class is from 25 to 29. The last one is from 40 to 45. Okay, these are age ranges. Then you have the individual scores. How do you find the individual scores, these X variables? Because this is very, very important. When you are given the class range like this one, 20 to 24, the question is that how do you know which one is your X? As your X, the individual score. You basically add the lower limit plus the upper limit, 20 plus the 24, then you divide by 2, okay? That gives us 44 divided by 2, and that gives us 22. So X is equal to be 22. You just add the upper limit plus the lower limit, or lower limit plus the upper limit divided by 2. Take the average of the class range. So from 29 minus 25, all right? Whatever you get, then you divide, oh, sorry, not minus, sorry, you add and divide by 2. So 25 plus 29 divided by 2 gives us 27. 30 plus 34 divided by 2, it gives us 32. 35 plus 39. 35 plus 39, then you divide by 2, gives us 37. And 40 plus 44, it gives us 84. You divide that by 2, it should give us 42, right? That's how you find these X variables. Whenever you are given the individual scores, you are given the grouped data where you have classes like these, please, the first thing to do is to find the X variables, okay? The individual score variables. And you find them by adding upper limit plus lower limit plus the upper limit divided by 2. And that is how we find this column. Is that clear?
Yeah, it's clear. And what of in case where you're just given single numbers, single digits of your,
okay,
there's
if
no
you are
upper
given
and
single digits like 20, 25, those will be your X's now. It will be your X's. That's an example of an grouped data, actually, what you're talking about. And grouped data where these classes are not in range, okay? You're not given a range, like you're not given a group. Just have the individual scores. Those will be your X's. Is that clear?
yeah, all right, it's clear.
Okay. Then the frequencies are always given like that. That is in this case, how many people had the age, aware of the age between 20 and 24? They were how many? They were just the 3 people, okay? According to this survey. Then the people that were between 25 and 29 were just what? 4. And so the people that were of the age between what? 30 and 34 were what? 35, isn't it? Oh, sorry, we're just 5. And those that were between 40 and 44 were just 5 again, just like that. Okay, that's how we find the frequencies. Now, to find the deviations, you just have the x variable minus the mean, okay? Have the mean. We have already calculated our mean. Previously, we did calculate them. Can you try to command your calculator 22 minus 65? Or 65 minus 22 maybe. That would be 3, is it?
It's 43. Negative 43.
It's negative 43. Okay.
Yes.
Yeah, so you need to find the mean first of these x variables. How do you find the mean of the x variables? Sum these x variables, okay? Sum them, and then you divide by how many they are. That will give you the what? The mean. Do 22 plus 27 plus, you know those things, right? So actually you multiply them with the frequency, like, sorry, you see frequency times the x variable divided by n. So you say frequency, what frequencies do you have? The summation of the frequency, of course. The frequencies are 3, so you say 3 times the 22, right? You add, you go to 4 times the 27, you add, you know these things, 5 times 32, you add. When you find the sum, you divide by how many they are. They are just how many, they are, the frequency, the total frequency. You sum the frequencies, okay? The total frequency, then you divide into that, that will give you the mean. So the mean is basically the summation of f of x divided by the summation of the frequency. Sum the frequency, and also sum the frequency times the x variable. When you find, when you're done doing that, that is how you find your mean, your x bar, your x bar. Then from there, if you have your x bar, it becomes that easy to do what? To find the deviations, because you're just having 22 minus the x bar that you find, okay? You find that, and you have 27 minus the x bar, okay? That is what happens. In case someone is wondering, you can still use this deviation to know how to find your x bar. You can, your x bar. We know that x minus what? Minus x bar is equal to negative 15, right? We know our x already. Our x already is 22. It's 22 minus x bar equal to negative 15. So we want to get the x bar. Then from there, you can collect like terms together. So it will be 22 plus 15. That should be equal to x bar, right? What do you find as the x bar? It should be 35, isn't it? Or 37. What is 22 plus 15?
37.
37. So 37 is your x bar. So from there, you can easily now solve all these things. If you have the x bar, which is 37, then it's easy. You can say 22 minus 37, that is the deviation. What do you find? Yes, you find a negative 15, isn't it? That is the negative 15. Then you can say 27 minus 30 what? 37, you find a negative 10 as your what? As your deviation, okay? The deviation is x minus x bar. You continue, do the same for 32 minus that, you have that. Then 37 minus 37 is 0. That's why you get 0 under the deviation. Then you can get now, what you do is this column is of the frequency that should be multiplied by the absolute of the what? Of the deviations, right? The absolute value of the deviations. The absolute value of deviation simply means you have these, make them the positives, okay? Make them the positives. Let them just be the positive. Relax the assumption. Let them be the positive. So you have 15 multiplied by what? By the frequency. The frequency is 3. So 15 times 3 is 45, right? That's what this frequency means. Frequency times the absolute deviation of that. 4 times 10. Okay, we have said it is absolute. So it's positive 10, not negative 10. So when you make it absolute, these two bars here, these bars, they mean absolute, which means the answer should always be positive. So it simply means 5 times this 5, it's 25. 6 times 0, 0, 5 times 5 of 25. That is how you have found this column, okay? That's how you find this other column here for that. Any question? Hello? Okay. So from there, now that you have found this, you can actually add the deviations, right? The summation of the deviations. Let me just zoom a bit. The summation, you can have the summation of the frequency times the absolute. The absolute of the deviations. This is the absolute of the deviations. So there is this column that we are summing up this side, okay? This column is continuing from the previous page. So you got 220. When you sum up those absolute deviation that are multiplied by the frequency. So absolute deviation times the frequency, you get that. You divide by the total n, the total number of the sample size, which is basically the summation of f that I said. You sum the frequencies. All those frequencies you find, you just sum them. The frequencies here, you sum them, okay? Just add them, you find total number of 30. And then you do your division, you find 7.3. Now this 7.3 is called an average deviation, okay? For the grouped data, of course, not for ungrouped data, for the grouped data. Is that clear?
Yes, it's clear.
If that is clear, then we can look at another measure of dispersion, which is called the variance. I think if you have understood the average deviations, the variance shall not be a problem. So the variance of a grouped data is given as the summation of the frequency times the deviation, right? The deviation squared divided by n. For the sample size, you can say n minus 1. Yeah, but because this n is for the population, but most of the times we use the sample. So we don't use the population, so it's better you leave it like that, n minus 1. Okay, that is the formula for the variance. So basically what you're going to find, or what you're going to observe, is that actually you're finding the deviations in the same way how you are doing it previously. You find the x variable that you find minus the bar, x bar, which is the mean, okay? You square that. After squaring that, then you multiply by the what? By the frequency, and then you add. You go on, you have the frequency times the x minus x bar, then you square that. You add everything. That is what summation means. After adding up everything on top, then you can have the total number of the sample size was total frequency minus 1. Total frequency minus 1 is the total frequency is 30, you can say 30 now minus 1, which will be 29. You divide into that, what you get is the variance. That is how you get the variance. So the variance is just more like the average of deviation, just minor differences in it. Then about the standard deviation. About the standard deviation. The standard deviation is basically the square root of the variance. The variance is found by saying summation of the frequency times x minus x bar. You square that, then you divide by what? By n minus 1, of course, for the sample size. That is how we find the standard deviation, ST. So the standard deviation and the variance, they still measure the same things. They measure the squared deviations from the mean. Okay, that is actually the difference, the distance of an individual score from the mean. How far is the individual score from the mean? That is the question being asked. So once you find your variance and you square root the variance, what you actually find is the standard deviation. If you don't square root the variance that you find, that is called the variance. But once that answer you find after calculating the variance, you square root it, that will be called the standard deviation. So basically, that's how you find the standard deviation of the group T data, especially when you're using the sample. Okay. Right. And so basically, that is what actually is happening. And you can see using the same example that we have been using of these people, these students. Someone got 68, that is your X variable. These are the deviations, right? Remember, these are the deviations from the mean. We found these as the deviations in the previous slide, as that other slide. These are the deviations. So when you look at these deviations, we say that these deviations are found by saying X minus X bar, the mean. Then we said you have to square them first for you to find the variance. You have to square them, right? You have to square them. So for example, you have this 3 here. You say 3 squared, okay? You say 3 squared. 3 squared will be what? Will be 9. 2 squared will be 4. 1 squared is 1. Negative 2 squared, like this, negative 2 squared. You put it in brackets first. It will give you 4, and the negative 4 squared will give you 16. That is what this parameter means, or this expression, X minus X bar squared, okay? Once you have that, you can basically add everything, sum everything, right? That is what summation of, this is sigma, this symbol, right? Summation of X minus X bar squared, that's what it means. So you are simply adding everything. Now start adding 9 plus 4 plus 1 plus 4 plus 16, everything. So when they summed everything, what was found is 34. This 34 refers to the summation of X minus X bar squared, which is actually the squared deviation, right? This is basically the summation of the squared deviations. And you find your 34. You divide by n minus 1. We said the total number of frequency. The total number of frequency is what you have to divide into, right? Get the total number of frequencies. So we are dealing with the students. The students are 5. So you can say 5 minus 1. That gives us 4. You say 34 divided by 4, okay? What you find is 8.5. This is called the variance, okay? This is called the variance. But if you square root this, or you square root the variance, you find the standard deviation. The standard deviation is actually the squared variance. So if you had just left this 8 point without the square root, you just remove the square root and solve straight. That what you find is a variance. That's what I just said previously. Then once you square root the variance, you find the standard deviation. So that's the idea behind the finding the standard deviation. Just square root the variance, then you would have found your standard deviation for the ungrouped data. What about for the grouped data now? How do you find the standard deviation of the grouped data? This is very necessary. Okay, standard deviation of the grouped data. I said the first column, you have the group, okay? Then from the groups that you have these X variables that you need the X variables. Remember in your formula, you have X minus X bar, you square that, right? You have the frequency like that and you sum that. There is that part, so you need the X variables. But the question is that how do you find the X variables? I said to find the X variables, you basically total up, find the average of the classes, say the lower class limit plus the upper class limit divided by 2. In that case, you say 20 plus 24 divided by 2, that will give you 22. 25 plus 29 divided by 2 will give you 27. And lastly, 50 plus 54 divided by 2, it will give you what? 52. Those are the X variables. So once you find your X variables, the frequencies are always given. You have these frequencies, okay? So what you do now to find the deviation, these are deviation now, X minus X bar. Find the mean the way how I've shown you how to find the mean. I said it's basically frequency times what? Times the X variable, right? How you find the mean of the grouped data, you say you sum the frequency times X divided by what? The summation of the frequency. So it is frequency, for example, here you say 22 times what? Times the frequency 3, plus again, you go to the other number, which will be 27 times 4. You keep on adding up to down here where you have, the last will be 52 times 3, okay? Then once you add everything, after adding everything, then you divide by the total frequency. The total frequency, you sum up these frequencies here. They total up to 30 minus 1. You say n minus 1, which will be 30 minus 1, that will be 29. So you divide by 29. What you will find actually, what you're going to find when you sum up everything, you find what is known as the total, which is the mean. Now, from the mean has been found. When we were calculating previously, we found 37 as the mean in the previous slides. So you say 22 minus, this is your X now, X minus X bar minus the mean. So you say 22 minus 37, which is the mean. You find what do you find? You find 15. Then you say 27 minus 37, that gives you 10, okay? Negative 10, of course. 37 minus 32 minus 37 gives us what? Gives us negative 5, and 37 minus 37 gives us 0. You continue going down like that. That is how you find this column for the deviations, okay? Once you find the column for the deviations, it becomes very easy now. You square these deviations. Now, when you're squaring the deviation, make sure you put them in brackets like this. You don't say just negative 15. You say, open the bracket, negative 15, you square that. It gives us 255. Open the bracket, negative 10 squared, that gives us 100, right? Open the bracket, negative 5, you square that, gives us 25. 0 squared is 0. 5 squared is 25, and 10 squared is 150. And then what else do you have? You will have another squared deviation, like 15 squared. You do 15 squared, you will have the number, okay? You'll have that difference, actually. Have that difference, right? This was actually an error here. Okay, have the number here. After that, now you are multiplying these numbers you have found, the X, these numbers you have found, these deviations, you have squared them already. You multiply them by the frequency. That is this column now. It is frequency times this deviation. So you say the frequency 3 times 250. it gives you 625, right? Then you have another frequency, 4 times 100, it gives you 400. Another frequency times the 25, it gives you 125. Another frequency, 6 times 0 gives us 0. Similarly, the last one, you do that, and then you are okay. Then from there, now in the formula we said to find the standard deviation, you should do square root the summation of frequency times the x minus x bar squared. Then you divide by n minus 1. So you're basically, to find this top numerator here under the square root, you sum up here, sum everything. Assuming that when you sum, you find 2,400 on top, you divide by n minus 1. Our n is 30, we have said is 30, the total sum of the frequency, minus 1, that will be 29. Then you square root the answer. So say 2,400 divided by 29, then the square root of that answer is called the standard deviation of the grouped data. That is for the grouped data now, not ungrouped data. So at least you have gotten the idea on how to find the standard deviation of the grouped data. So basically, this is what occurred. So 2,400 divided by 29, that was found. You divide that, you square root that, the square root thereof is 9.1. This means that on average, each individual is expected to have deviated from the mean by how many marks? 9.1 marks. That is the difference, the deviation from the mean. Okay.